From the earliest discovery of kites in China in the early 400 BC, to the Wright brothers flyer that took the first real step toward modern flight in 1903, humanity had been preserving to perfect the art and science of human flight, pushing boundaries in the name of innovation. Presently, a lot of us take for granted humanity's monumental achievement. What used to take years to cover a few thousand miles can now be achieved in a matter of days or even hours. Modern airplanes and the airport system, although sometimes susceptible to being late, have achieved such precision that even an hour of flight delay is still a miracle of human innovation in the grand scheme of things. In 1969, humanity wanted to take another step into uncharted territory. The Concorde plane by Air France took its first mighty flight. Unbeknownst to everyone, this engineering marvel would be involved in one of the most horrific cases of flight accidents in history, 30 years after it is first introduced to the public. On July 25, 2000, passengers boarded the Air France flight 4590. The route was from Charles de Gaulle International Airport in Paris to John F. Kennedy International Airport in New York, United States. Upon landing in New York, the passengers were supposed to board a cruise ship that would take them to Ecuador in South America. Flight 4590 was actually a chartered flight, which meant that it wasn't part of the airline's regular scheduled trips. These types of flights were more expensive than regular commercial flights. The plane they boarded is the Aerospatiale BAC Concorde. This model of an airplane was a cut above the rest of the world. It was jointly developed and manufactured by two large aircraft companies, Sud Aviation, which was later named Aerospatiale from France, and the British Aircraft Corporation, BAC, from Great Britain. The people that spearheaded this program wanted to create an airplane that can run at supersonic speeds, which were unheard of at the time, all the while making it accessible to the general public. In 1965, the cost of developing the Concorde program was approximately $400 million, revised later to $770 million, and then to $1.26 billion, $1.75 billion, and then finally, in 1977, more than 10 years after its first estimation, the British government quoted that the development, production, and operating costs for the Concorde reached a whopping $4 billion. While American-made supersonic jets like Boeing and Lockheed were hindered by budgetary and environmental problems, the Franco-British Concorde project led the commercial supersonic competition. It was a result of the Cold War's technological race, and so at the time, it was truly state-of-the-art technology. The Concorde could fly at an altitude of 60,000 feet, while normal jets fly only at 30,000 feet. Flying at this high altitude lessened drag and lift because of the thinning air, which increased the plane's maximum speed. It could reach up to 1,350 miles per hour, while regular commercial passenger aircraft were only at the maximum of 600 miles per hour. With this speed, the Concorde could travel from London to New York in less than 4 hours, which was half the time of regular jets. The Concorde first flew on March 2, 1969, albeit the plane was only in the air for 27 minutes. The engineering marvel's feats were on full display. In its 24 years of commercial operation, it never had a fatal accident. However, everything changed after that fateful day on July 25th. To completely understand the events that took place on that day, we have to know a bit about the design of the plane so we know what went horribly wrong. The Concorde had an interesting design built for speed. It had delta wings, which were quite uncommon for commercial planes at the time. Delta wings were named after the Greek uppercase letter delta, which is triangular shaped, hence the interesting shape of the wings. The reason for using delta wings on Concorde was because the designers deemed that it would be good for subsonic, transonic, and supersonic speed ranges. These are simply categories of speed that the plane can enter during flight. Subsonic means that the speed was less than that of sound. Transonic means that it's close to the speed of sound, while supersonic means that it is faster than the speed of sound. However, the Delta wing design had a couple of issues which all related to the way a plane took off. Firstly, on the runway, the Concorde plane needed to undergo very high speeds. For comparison, the Boeing 737 only needed speeds of 140 to 150 knots to achieve takeoff, while the Concorde would need to reach speeds of up to 200 knots. This was crucial because those speeds would put enormous stress on the tires. By 1982, Concorde was having a lot of issues to the point that the landing gear and tires had to be inspected before every takeoff. Additionally, in 1985, 1988, and 1993, a series of serious incidents involving tire bursts led to pieces of landing gear or tire rubber going inside the plane's engines. This punctured the tanks and caused fuel leaks. As a result, people began questioning Concorde's airworthiness, the legal and physical state of an airplane's design, and in turn, a lot of efforts were made to strengthen the landing gear and tires. The second issue was that the Concorde plane needed a high angle of attack, AOA, to achieve takeoff. This was the angle at which the airplane's wing met the wind. As the angle of attack increased, both lift and drag also increased, which may lead to loss of control and altitude. Concorde's Delta wings design would need a high angle of attack of about 18 degrees. Meanwhile, passenger planes had a lower angle of attack at around 10 to 12 degrees. The Concorde's fuel system consisted of 17 tanks situated across the body of the plane. At its rear and front, there were trim tanks. These tanks transferred fuel towards the middle tanks to achieve a desirable center of gravity when the plane took off. Later, during flight, when it reached supersonic speeds, the aircraft needed to maintain balance, and in effect, the fuel needed to be pumped back into the trim tanks. The Concorde had 4 powerful Olympus engines that were situated under its wings. These had afterburner capabilities, giving the plane an additional 18% level of thrust. On July 25, 2000, Air France Flight 4590, consisting of 100 passengers who were mostly German tourists, prepared for its flight to JFK International Airport. As the departure time drew near, the dispatcher was going through his usual routine when he noticed that the flight had some technical issues. Firstly, the thrust reverser for Engine 2 had a problem when the plane arrived from its trip the previous day. This was the part of the plane that slowed it down when landing or used to help stop the plane if it experiences a malfunction just before takeoff. Secondly, in checking the load manifest document, the dispatcher realized that there was a mishap in the Air France system. Most of the luggage arrived late from Germany and wasn't actually in the document, so he took the information to the flight crew. Although the manufacturers of the Olympus engines knew about the inoperable thrust reversers, according to them, it shouldn't be a problem and the plane could still fly without it. However, the pilot insisted on getting it replaced. The engineering department was contacted and they replaced it using a piece from a backup Concorde plane. It only took 30 minutes before the plane was given a go signal. Unfortunately, the mishap with the luggage wasn't fixed, and in the end, Flight 4590 had 19 more bags than allowable. Later, the 3 pilots, namely the captain, the first officer, and the flight engineer, proceeded with their pre-flight inspections in the cockpit. The captain was 54-year-old Christian Marty, who had 13,477 total flying hours, 317 of it flown with the Concorde. The first officer was 54-year-old Jean Marco, who had 10,035 total flying hours, 2,698 of it flown with the Concorde. Also, he was a Concorde simulator flight instructor. Lastly, the flight engineer was 58-year-old Gilles Jardinot, who had 12,532 total flying hours, 937 of it flown with the Concorde. In summary, this was a very experienced flight crew, which was typical at the time for Air France's Concorde. The qualification process for flying Concorde was very selective and consisted of only about 30 people. Later, the flight engineer checked the thrusters and came back to the captain. He informed them that the thrust reversers were now fully functional, which meant that they can load as much fuel as they needed. Afterward, the flight crew agreed on loading up 95 tons of fuel. Shortly after, they calculated and agreed on those values. V1 at 150 knots, VR at 198 knots, and V2 at 220 knots. V1 was simply the speed limit that the pilot can decide to abort the flight if an emergency occurs. With this specific flight, if an engine fails beyond the speed of 150 knots, the pilot has no choice but to take off, or else it might lead to a runway overrun or severely damage the plane. VR, or rotation speed, was the speed at which the aircraft is initiated for takeoff. Rotation speed should always exceed V1. This can be remembered as the speed at which the plane's nose leaves the ground. V2 was the speed at which the aircraft can be initiated for takeoff in the event of one engine failure. Afterward, the dispatcher communicated with the captain to inform him about the taxi fuel burn, which was approximately 2 tons. This was the measurement of how much fuel will be used during taxiing, or when the plane is on the ground, to achieve takeoff. The figure given by the dispatcher would be crucial later in the event. Around 4:25 p.m., after an hour of delay for the scheduled flight, the flight crew asked for startup clearance. This was the permission from the air traffic controller for the captain to start the engine. The captain started the engines. Engine 3, from the right-hand wing closest to the body, was ignited. Then, Engine 2, from the left-hand wing closest to the body, was ignited. Finally, engines 4 and 1, the engines furthest from the plane's body, were ignited. Afterward, the flight crew asked for taxi clearance. The plane would be using runway 26R, which was one of the longest runways on Charles de Gaulle Airport. At first, the air traffic controller asked if they can have an intersection takeoff. But the captain responded that due to the plane's current weight, they would need full runway takeoff. The air traffic controller granted them taxi clearance, and around 4:35 p.m., Air France Flight 4590 was moving to the runway holding point. While Flight 4590 was on its way, a DC-10 from Continental Airlines was currently lining up for takeoff on the same 26R runway. As it sped down the runway, a short metal strip of about 43 centimeters dislodged from the right-hand engine of the plane. Unfortunately, because the flights for DC-10 and Concorde were only minutes apart, no inspections were made on the runway to alert Flight 4590's crew. Additionally, at the time, only 2 runway inspections were mandated per day. This small piece of metal left on the runway would turn out to be one of the primary reasons for one of history's most tragic airline accidents. As Flight 4590 neared the runway holding point, the captain briefed the cockpit crew and outlined what they would do in an emergency. He stated that at 0 to 100 knots, or low-speed regime, they would stop the plane for any warning or possible mishap. Then, at 100 knots to V1, which, if you remember, was at 150 knots, they would only stop the plane for engine fire, engine failure, or tire flash. This was an indicator that signaled to the cockpit that a tire lost some of its pressure. Afterward, the captain asked the flight engineer how much fuel they burned off during taxiing. The flight engineer responded that there were still 800 kilos in the tank. This was problematic because, according to the calculation as mentioned by the dispatcher previously, the plane would be using 2 tons of fuel during taxiing. This would mean that the plane would be 800 kilos overweight upon takeoff. The flight engineer notified the captain that the brake temperatures were at 150 degrees Celsius on both sides. At 4:42 p.m., Flight 4590 was cleared for takeoff from runway 26R. Over the next 121 seconds, the German passengers who were eagerly waiting for their cruise ship to South America would experience unimaginable terror. At 4:42 p.m. and 30 seconds, the captain advanced and initiated the 4 massive Olympus engines. This sent the aircraft quickly accelerating down the runway. At 4:42 p.m. and 54 seconds, the first officer and flight engineer checked the 4 goal lights and they saw green. This indicated that all the engines were working normally. 6 seconds later, nothing happened, and Flight 4590 reached V1 speeds at 4:43 p.m. as the first officer confirmed this. At this point, the airplane could no longer halt or abort the takeoff. At 4:43 p.m. and 9 seconds, the plane was now running at about 160 knots when it suddenly passed over the metal piece that came off the DC-10 previously. As a result of running over it, the water deflector from the left-hand side landing gear of Flight 4590 broke off. The cockpit crew saw that the plane slightly steered to the left. At 4:43 p.m. and 9.5 seconds, one of the tires in the left-hand side landing gear exploded and was heard from the cockpit. In just half a second, the damage to the tires from rolling over the metal strip caused it to explode. At 4:32 and 10.5 seconds, things started to take a turn for the worse. Flight 4590 accelerated to a speed of 178 knots. Remember, since they were well past V1, they could not abort the takeoff, even though the pilots and the flight engineer clearly knew there was something wrong with the tires. The explosion from the tire previously caused rubber debris to hit the underside of the left-hand fuel tank. Since the plane was running at such high speed, the rubber debris hit the tank with incredible force, causing it to warp inward. Because the tank was at full capacity, the fuel had nowhere to go, and so this caused a rupture from the inside and massive amounts of fuel gushed out. All of this happened within the span of 1 second since running over the metal piece. To make matters worse, the ruptured tire exposed some of the electrical wires, and in the ensuing leak, the fuel ignited. Shortly after, the aircraft veered strongly to the left due to the damaged tires and the drag caused by the now massive flame. The captain attempted to counteract this by adjusting the rudder. At 4:43 p.m. and 12.5 seconds, the aircraft started to lose thrust on engines 1 and 2, which were both located on the left-hand side. With engine 1, it ingested the debris from the broken tire, causing it to malfunction. Meanwhile, engine 2, which was closest to the frame, was ingesting a lot of hot gases, causing it to malfunction as well. The first officer and the flight engineer noticed the goal lights for engines 1 and 2 were now turned off, indicating there was a serious problem with both engines. The plane accelerated at 187 knots while continuously steering to the left due to the damaged engines on its left-hand side. Despite the captain's efforts to counteract this, the plane persistently veered off from the center line. Realizing that the plane might completely go off the runway, the captain decided to rotate the plane slower than usual since they have not gained enough speed for a full and proper rotation. At 4:43 p.m. and 13.5 seconds, the flight engineer commented that engine 2 had now failed. However, engine 1 was actually starting to gain thrust again. Unfortunately, at the same time, the plane was taking off and this caused the wind angle to change and push the hot gases back into the recovering engine. Soon, both engines lost thrust. The fire alarm rang in the cockpit, so the captain told the flight engineer to proceed with the fire engine procedure. The air traffic controller called the captain to let them know that the plane was in flames. As the flight engineer lowered the thrust for engine 2, the fire alarm temporarily shut off, but quickly it came back on again. This was because engine 2 was not actually on fire, but because it was so close to the massive flame, the sensors were feeling the hotness of the flame, thus signaling the cockpit. Shortly after, Flight 4590 became airborne. However, the crew now faced a different problem. If you remember, the captain previously decided to take off at a slower speed, so in consequence, the flight speed is also slower at 200 knots instead of 220 knots, as they previously agreed in the pre-flight preparations. With the current weight of the aircraft and the weakened thrust of engines 1 and 2, it was impossible for them to maintain their altitude, let alone climb it. The first officer notified everyone that their airspeed was less than desired. Meanwhile, engine 1 was heavily damaged, but still had some thrust. However, engine 2 was shut down due to the fire procedure. Engines 3 and 4 were now compensating for the loss of the other engines by producing as much thrust as they possibly can. However, this was not enough. Soon, the air traffic controller called to tell them that they should prioritize returning back due to the massive flames still trailing behind the plane. The flight engineer reminded the first officer to retract the landing gears. However, he did not acknowledge this because according to protocols, when the landing gear is damaged like theirs, it should not be retracted. The captain overrode this with a direct order for the flight engineer to retract the gears. Unfortunately, the gears had been damaged to the point where they could no longer be retracted. The captain was notified that engine 2 had been shut down, while the first officer reminded them of the slow airspeed. At 4:43 and 55 seconds, still airborne, the aircraft began to roll to the left on its own. This was caused by the massive flames melting the left-hand side wing. The captain noticed the situation and counteracted by pulling to the right while trying to climb altitude. At this point, the air traffic controller reminded them to return immediately. Unfortunately, the captain deemed it was too late. He told the crew, "Too late, no time." The first officer read this back to the air traffic controller and said, "Les bouger, negative, we are trying les bouger." Because the crew could not turn around to Charles de Gaulle, they decided to attempt an emergency landing at the nearby Les Bourget airport. In the cockpit, the fire alarm rang loudly as engines 1 and 2 completely lost thrust. The aircraft further rolled to the left, reaching a dangerous 113-degree angle. A feeling of dread loomed over the 3-man flight crew. In a desperate attempt to gain control of the plane, the captain ordered the first engineer to undo the fire procedure and bring back engines 1 and 2 into full thrust. However, it was too late. At 4:44 p.m. and 31 seconds, Air France Flight 4590 crashed into a hotel in Nice, a small town near Charles de Gaulle Airport. In just 121 seconds, all 109 people on board the Concorde perished, along with 4 people in the hotel. At 4:45 p.m., the air traffic control informed the fire and emergency services. After the initial chaos and search for survivors, investigators went through the crash site. They quickly found the Concorde's landing gear, but it was missing a piece called a spacer. This part was essential in keeping the wheels at a perfect angle to maintain the aircraft's balance while taking off. As they scoured through the crash site, they could not find the missing spacer. Some started to wonder if it was even at the crash site, so a team got sent in to investigate. In their search, they found that the spacer was in a workshop where the Concorde underwent maintenance a few days before the flight. This was a serious oversight from Air France, however. After going through the data, they concluded that the missing spacer would not have affected the performance. Remember when the captain asked the flight engineer for the temperatures of the brakes? The flight engineer said it was the same, which indicated that the landing gear was actually aligned well at the time. If it were not, the temperatures would have been different. The investigators turned to the DC-10 that took off on the same runway minutes before the Concorde. In their investigation, they learned that the metal strip had been replaced twice already in the previous 2 months, and that it was not manufactured according to the manufacturer's manual. Finally, the investigators turned to how the pilots performed. Unfortunately, the situation was simply too complicated for them to respond properly. The broken landing gear, the fuel leak, and worse, the massive fire was not a scenario done during flight training. Additionally, the investigators deemed that if instead of rotating the plane, the captain decided to abort the takeoff, it would still have ended disastrously. After they ran over the metal strip, they were already accelerating at such a high speed that stopping the plane would have caused the landing gear to collapse, and with the flames behind them, the plane would have exploded. In conclusion, there was very little that the pilots could have done to prevent the unfortunate incident. We all know how frightening an airplane disaster can be, whether you're thousands of feet in the air or speeding at 150 knots on the ground. There's little to nothing that you can do if things do take a turn for the worse. However, nowadays, airplane safety measures have greatly improved, and there's very little chance of catastrophes as horrible as this one. Despite this, we must remember that the 109 people on Flight 4590 thought it was a regular, uneventful day. Until it wasn't. If you're still here, thank you. I hope this doesn't give you the fear of flying. Terrible tragedies, especially ones that start off as mundane, are hard to hear. However, it is important that we learn about these things and realize that these people existed once. The more people know about things, the better the world will be. Now, if you enjoyed the video, please let me know by hitting the thumbs up button, commenting your thoughts below, subscribing to our channel, and hitting that notification bell for more videos like these. See you on the next one.